let us discuss a little bit deeper into the naive Bayes classification algorithm by making two changes here. The first change in this example is pretty straightforward. The second thing is kind of hidden, and we will look into that. So let's take a look at this. Now, say now we have the same training data set. However, instead of predicting a person is going to buy a computer or not, which means that we use computer purchase as a label, we now make that as simply an attribute, and we want to predict a person's income based on the age attribute, student status, credit rating, as well as owning a computer or not, to predict the income. So this is totally possible to do so. And now, when we look into this case, by using naive Bayes classification, you see that the label we want to predict has three different categories now. So we have income equals to high, income equals to medium, income equals to low. This is something very different from what we have discussed not only in naive Bayes classification algorithm as well as in decision tree, because previously you only have what we call by class classification. We make prediction for two classes, yes or no only. In this case that we are looking at has three different cases. So you can try to predict a person income is high, medium, or low. And by using the same concept, you see that we can also using all of these four attributes to predict a person's age based on the training data set. So all kind of things are possible. And in this additional example we want to discuss, now let's take a look of a non-by-class classification prediction. So again, we want to use age, student status, credit rating, and owning a computer or not to predict a person's income. So since income has three different classes, and we want to make our naive Bayes hypothesis equals to three different hypotheses. And we will do the same thing to calculate the probability of probability of high, probability of medium, probability of low for the example data, testing data sample that we have seen over here. So now this person is age equal to 30 to 40, not a student, excellent credit rating, and he does not own a computer. And based on this information, we want to predict his income is high, low, or medium. So let's see, how do we do that? Since we starting with three classes, we need to get the probability of each class. So income equals to high has four cases here. We have four cases of high income based on the data, 6 medium income, 4 low income. So we have these probabilities for the three different classes. So now, in order to make our prediction, we need to dissect each attributes one by one. So starting from age, since the age is between 30 to 40, so we look into the age, we pick up all 30 to 40 ages coming out, and then we try to map them for their income. So that's how we can get the first attribute. Now, the first one, since we have 2 out of 4 age between 30 to 40, we have 2 of that, and that is occupying 4 high income people. The same thing, income equals to medium totally has 6, and in this age category we only have 1. The same thing for the low income, so we only have 1 out of 4. So if we only look into this one, there's a good probability that this is actually a high income status. Student. So based on the scenarios, income, high, low, and medium. So by looking into the income, high, low, medium for not a student, so we have 1, 2, 3, 4, 5, 6, 7. We have 7 non-students situations over here. So when we look into their income mapping, 3 of those are mapped onto the high income. So by this attribute, let's actually have a very high probability of an income high, again, in this attribute. For the medium income, 4 out of 6 is representing the probability here. The minor problem, remember I said there are 2 special things that we want to look into this case. This is what I'm looking at. If the income equals to low, and the student is not a student, in this case, there is actually no cases over here because we only have 7 non-students. 3 of them are high income, 4 of them are medium income, and there's actually no one is representing non-student and low income over here. This is reflecting the training data set's information. So simply we map into the data that we have over here and then try to calculate the probability based on our training data set. It's not saying like the regular data or something. This is just our target training data set. And therefore you can see that with a large amount of training data set is something very important. Let us take a look of this 0 over here. Let me tell you, it will have high impact later, and we will see that pretty soon. So we want to do the same thing for the excellent credit. We try to look into that one, finding out there are 6 excellent credits, and we distribute them into high, medium, and low income. And we will do the same thing for buying a computer or not over here. So we have all the information that we need now, and all we need to do is that we can simply try to calculate the probabilities for each hypothesis. And so let's do that. What we can see over here, the probability. The first one is pretty straightforward. We get all of the high incomes probability out of 4 attributes, multiply the values together. Medium doing the same thing. Now this 0 has high impact, and that's something not right because it has a 0 over here, indicating that in our training data set we never see this case on this attribute before. While we get a 0 over here, you know, if we multiply anything with 0, we get a 0. Maybe they have actually, in our training data set, we have very high values for our other 3 attributes, and because of this just one instances, and this is not really some errors over here. This is like we never see this case in our training data set. This is not really saying that this cannot happen. So how do we handle this 0 become a very big issue over here? And so that we see there's further improvements possible in our naive Bayes theory. And we of course don't want that this 0 stands on the way and cancel out all other attributes. And that's going to be the scenarios that we want to discuss in the second videos about the naive Bayes classifier. Therefore, we need to introduce, there are 2 ways, and of course there are many ways, 2 easy ways of handling that. The first way of doing that is that we just simply ignore this 0. Of course, that may introduce some unfair scenarios with all other situations. So that's something not as good as the way of handling this situation. And that's why the other one is what we call laplace smoothing. So we want to smooth this 0 out to reduce its impact while still reflecting some regular or some plausible probabilities over here. So that we want to introduce slightly more complicated operations into our naive Bayes theory. So you can see that what this adding over here is a lambda with a k multiplied lambda. On the other side, it's still a lambda with a multiplied by lambda. It may look a little bit complicated, but that's, if we try to understand it correctly, it's actually not as bad as it is. So what we want to do over here is that for the probability of the case that we are looking at, since in the example we see there are 3 scenarios, high, low, medium income. So there are 3 scenarios over here. When we try to calculate the probability of that, we want to add a lambda over here for the upper part of the equation. So we can, for simplicity, we can consider lambda as 1. So you can see that we add 1 over here, and therefore whenever we have a 0 situation, it will not having a minimum value of 0, it will have a minimum value of 1 in this case. Divided by n plus k multiply lambda. Again, if our lambda is 1, k is representing how many classes that you have. In this case, we have 3 classes. So for the lower part of the equation, we will have whatever values that we have plus 3 multiplied by 1 equals to 3. So that's how we can calculate the probability of our classes. On the other side, when we are looking for each attribute, we do the same thing. For the upper part of the equation, we plus lambda, and basically, if we set lambda equals to 1, which is the most common scenarios, again, we will have our minimum value of 1 instead of 0, and that can totally cancel out that 0 situation. Similar things, we will divide it by the regular original values plus A is indicating how many classes for this attribute, multiply lambda, and that's actually can solve the whole problem. And let's add that concept into the examples that we see. Again, since we have 3 classes over here, so we have 3 classes over the income, and therefore what we can see is that we have probability of high, medium, and low. And now we still have all the values. Originally we have 14 cases. 4 of them are high, 6 of them are medium, 4 of them are low. Now by adding the Laplace smoothing, you see that we add 1 for the upper part of the equation for every single one of that, and divide it by, since we have 3 cases, multiply lambda equals to 1, we add 3 on all cases of them. And therefore, the probability has changed into this value. So it's not exactly the same with the original value, but they are close enough. And we can solve that 0 problem. So now once we know that, what we can do for each attribute, what we are going to do is we do the same thing. For the age, because there are 3 cases, so you can see that for the lower part of it, we add 3 for every single one of that. For the values that we get, we add 1 for every single one of that. So now we will not get a value of 0. So it's not actually changing a lot in the age, but it changes a lot. It changes a whole prediction probability in the student scenario. So now you can see that we have 2 cases. So that's the difference. Since student has only 2 classes, yes or no. So you can see that for the lower part, you plus 2 for every single one of that. And for the upper part, you add 1 for every single one of that. That changes this scenario, this probability, from 0 to 1 out of 6. And that changes the whole story. So we will do the same thing. Create it because there are 2 classes. So we plus 2 for every single one of that, and then plus 1 for every the upper values. And for the computer, we add 2. Again, it has 2 classes only, so we get all of the probabilities here. Now, in order to calculate our probability for the hypothesis, we can multiply all of their values as what we get over there, and you can see that there is no zeros anymore, and every single one of that can contribute the probability. And of course, the end of that is we will need to multiply the smoothed probability of the each income category. So now we have these 3 final results over here to make the comparison. And of course, we are going to predict the one with the highest probability, indicating that this case that we want to make the prediction, because of the naive Bayes theory with Laplace smoothing, we are predicting his income is going to be high.